get started on the area of any triangle, we first must establish some basic formulas. So let's say we have a right triangle and it has legs B and H. So if we wanted to find the area of this triangle, how will we do that? Well, the critical insight comes when we duplicate this triangle. And you can see that they both have 90-degree angles. They both have legs of H and B, and they also share the same hypotenuse. So another thing to note is that, say we call this angle alpha and this angle beta. So within the first triangle that we drew, the one that I'm circling in red, we know that alpha plus beta plus 90 degrees is going to equal to 180 degrees. Let me redraw that. It's going to be equal to 180 degrees. And this is because there's only 180 degrees in a triangle. Well, we can rewrite this as alpha plus beta equals to 90 degrees. And this is because we can just subtract 90 degrees from both sides of this equation to get this. So we know that alpha plus beta is equal to 90 degrees. So if we look at the two triangles that we just constructed, I'll draw in the other angles. So this angle is going to be beta, and this angle is going to be alpha. And this is just because, well, because we duplicated and we kind of flipped it. So this would be where alpha ends up. And you can also prove this because these two lines are also parallel because of the way that we duplicated it. So by alternate interior angles, this must be alpha and this must also be alpha. And same thing with beta. If these two lines are parallel because of the way that we duplicated it, well, this angle must be equal to this angle. So we know that this is alpha, so we know that these corners have an angle measure of alpha plus beta. Well, alpha plus beta is just 90 degrees. So these corners must also have a value of 90 degrees. So these are actually all 90 degrees. So I'm going to erase the angle markings now because they won't be necessary. I'm also going to erase this. So now, if you will see, we basically have a rectangle. So if we wanted to find the area of this rectangle, well, that would just be base times height, because you have, let's say, you have b amount of things along here, all with a length of h. Well, the total amount of things that you have would just be b times h. So this is the area of the entire rectangle that we constructed. But what about just the triangle? Well, if you'll see, the rectangle is going to be equal to two triangles. And this is because these two triangles are congruent. So this triangle and this triangle are congruent. And there's a lot of ways to prove this. For one, they're congruent because of SSS, side side side. So that's how we know that these two triangles are congruent. So the rectangle is going to be equal to two triangles. So if we wanted to find just the area of one triangle, well, then we could just divide both sides by 2 and get that it just be 1/2 of the rectangle. And what is the area of the rectangle? Well, it's 1/2 base times height. So that's how we know that the area of a triangle is 1/2 base times height. So this is only for a right triangle. What about other triangles? What about any triangle? So let me erase all this stuff for a little bit more space. So let's say we have this triangle, and I'm going to construct a line that drops straight down from one side and touches another side. And it's going to be perpendicular to this line segment over here. So how will we find the area of this triangle? Well, essentially we can just do the same thing that we did over here, which is construct a rectangle. So we can basically just draw in some lines, and using the same logic that we did before, well, this is also a 90-degree angle because this entire line segment must be 180 degrees. And because we duplicated all of these these triangles essentially, well, we know that I'll just draw the congruencies right now. We know that this triangle and this triangle are congruent, and we know that this triangle and this triangle are congruent. So I'm going to call this triangle A and this triangle B. So the area of the entire rectangle is going to be equal to 2A plus 2B. We can rearrange this to get that the triangle or the rectangle is going to be equal to 2A plus B. So if we just wanted to find A plus B, we can rewrite this as A plus B equals to the triangle or the rectangle over 2. And notice what A plus B is. A plus B is just going to be the original triangle that we wanted to find. So from this equation, we know that we must find the area of some rectangle. So if we could find, let's say, if we knew the base of of this thing and the height of this rectangle, then we could find the area of the rectangle, and by extension, we could also find the area of this giant triangle over here. So that's pretty much all we need to know. Now we can get on with the actual proof. So let's say we construct a giant triangle, and we're going to draw a line that goes straight down. And we're going to call this triangle ABC. So there's going to be an angle of A here, angle of B, and an angle of C. And also draw on the side lines A, B, and C. So if we wanted to find the area of this giant triangle, we know that it is equals to 1/2 base times height. And we proved it last time because we knew that the area of the triangle is going to be equal to the rectangle over 2. Actually, if I remember correctly, it was A plus B equals to the triangle. Let me rewrite that. It was A plus B, the two triangles, was equal to the rectangle over 2. And the rectangle is just, the area of the rectangle is just base times height over 2. I'm going to rewrite this as 1/2 base times height. So that's how we know the area of a triangle is this. So the base of this triangle is going to be A. Now, actually, I'll rewrite A in a different color. A. And the height is going to be the line segment that we drew over here. Height. And I'll write that in blue. However, we're not given height. We're not given height. We have to find out what the height is. So sine of C. Actually, let me do this in white. the sine of C is going to be equal to opposite over hypotenuse, which is equal to h over b. And we can rearrange this to get that h, the height, is equal to b sine c. And we did this by just multiplying both sides by b. So now that we know what h is, well, we can just substitute it into this equation. So the area of the triangle ABC is going to be equal to 1/2 base times height, or A times B sine C. And this is the formula for the area of any triangle. If this video has given you value, or you appreciate this concise, no BS way of teaching, then please consider supporting the channel. Regardless, thank you for your attention and good luck in your studies.